Hello all. So let us discuss the problem on the topic convolution neural network. So here we are going to consider an input image as a matrix and we are going to apply the convolution operation on the given matrix. So let us look into the problem. Consider the following data representing the image, that is X. X is represented as an image here. Apply the following operations and find out the output. So we are going to find out the output matrix. That is our objective. So the operations we are going to perform is we are going to do the convolution with padding. Padding here is considered as the same padding and the given stride is equal to 1. And the second one is we are going to apply the pooling operation. Here the given pooling operation is average pooling. So where we are going to consider the stride as 2. So now see here it is the given matrix X. X represented as an input image. Here the size of an input matrix X is 4 cross 4. So it can be represented as W1. So what is W1? W1 is the width of the given input matrix. So it is considered as 4. And then F, F is a matrix where the size of the F matrix is 3 cross 3. This F is called as an filter, or we can call this as an kernel. So now the size of the F is equal to 3. So our objective is to find out the output matrix where the width of the output matrix is considered to be W2. So in order to find or in order to predict the size of the W2, we have a formula. So W2 is equal to W1. So what is W1? W1 is the width of the input matrix minus F. So F is the size of the filter plus 2 into P. So here P is called as a padding divided by S plus 1. S is called as an stride. So from the given problem, W1 is equal to 4, F is equal to 3 and P is equal to 1. Since the given padding is same, if it is same padding, P is considered to be 1 and S is equal to 1. So now we are going to apply all these in the formula. So W1 is equal to 4, 4 minus 3 plus 2 into 1 divided by 1 plus 1. So 3 plus 2 it is 4 minus 3 it is 1. 1 plus 2 3. 3 divided by 1 is 3. 3 plus 1 is equal to 4. So the size of the matrix, the size of the output matrix where we are going to find should be 4. That is 4 cross 4. Okay. So now see here. So since we are going to apply the same padding in the given input matrix, meaning that we need to append zeros on the corner of the given matrix. Okay. So this is called as an same padding. So instead of same padding, if it is asked as a valid padding, valid means we need to keep the input matrix as it is. So no need to append the zeros on the given matrix. Okay. So we have two options. One is same padding and another one is called valid padding. If it is the same padding, we need to apply the zeros on the corner of the given input matrix. We are going to get the output matrix Y. The size of the output matrix is 4 cross 4. So we are going to apply this filter on the input matrix to find each and every element of the Y matrix. We are going to perform the convolution operation. So for Y11, we are going to consider 3 cross 3 values in the input matrix, applying this filter on this matrix. So doing element-wise multiplication and summing up all the products, we will get 3. So the value for Y11 is 3. So next we are going to find out Y12. So for Y12, we are going to shift this input values towards the right side in the given matrix. Since S is equal to 1, we are going to shift by 1 unit. Now this is the input value for Y12. So this filter is applied on this Y1, this input matrix. to get y12. So see here, so again we are going to perform element-wise multiplication and then summing up all the product terms, the output value is 2. Similarly, to find y13, shifting this input values towards right side for 1 unit. So again, this is the input matrix and this filter is applied on this input matrix to get y1. So similarly, the y13 value is 2. And again, we are going to shift this towards right side, that is in horizontal direction. Now, this is the input matrix. This filter is applied on this input matrix to get y14. So the value for y14 is 3. So we have done with the horizontal direction for the first row in the output matrix. So now we are going to find out the second row values. So to get second row values, that is y21, we are going to shift this right towards the vertical direction by 1 unit. So that now this is the input matrix for y21. Shifting this value towards right side in horizontal direction in order to get y22, y23, y24. So similarly, the element-wise multiplication is performed between the input matrix and the filter to get the second row values. So again, shifting this input values towards vertical direction for y31. So for y31, and this is for y32, and this is for y33, and the last one is for y34. y34. So this is what I have done here. y31, 32, 33, and 34. So similarly, we are going to shift the values towards vertical direction in order to get the value for y41. So this matrix is for y41, shifting 1 unit right for y42, and this is for y43, and the last one is for y44. So applying this filter on all these matrices to get the values for fourth row. So this is what I have performed here. So now we are going to write the output matrix Y. So output matrix Y is equal to 3, 2, and 2, 3, minus 1, minus 3, minus 3, minus 3, 3, 3, 3, 1, and the last row minus 2, minus 2, 0, 2. So this is the output matrix after performing convolution operation with the given filter. So see here, so we cannot able to move the scribe anymore towards the horizontal direction as well as in vertical direction, since we cannot able to multiply with the filter. So this is the output matrix. So similarly, we are going to find the value for average Boolean for the given input matrix. I have performed here average Boolean. So this is the given matrix, X matrix. To perform average Boolean with the size 2 cross 2. So the matrix size is 2 cross 2. That is what given in the question. See here, 2 cross 2. Its stride is equal to 2. So meaning that we are going to move the values towards horizontal as well as vertical direction 2 units. So average Boolean. So this is so we are going to perform the average Boolean with this 2 cross 2 matrix, that is with the pixel values. So 1 plus 1 plus 1 minus 1 divided by 4. Since we have 4 values, 4 elements, so it is divided by 4. And then average between this and average value of this, average value of this, and this is the output matrix, the X after applying average Boolean. So similarly, we can also perform max Boolean. So if it is asked for max Boolean, you need to find out the maximum value in the given pixel values. So that's all about this problem. Thank you.